Hey everyone, SrIrH here. Today we're going to talk about imaginary phonon modes. Think of them as strange, impossible vibrations in your crystal model, like your atoms are moving in ways that just can't happen in real life. When you see these, it usually means your simulated crystal isn't stable. Our mission? I'll show you 7 practical tips to get rid of these odd vibrations, using the tricky case of SrIrH₈ under 100 GPa as our example. Let's dive in. Let's talk about supercell size. If your simulation box is too small, you might see imaginary phonon modes that aren't real. For SrIrH₈, start with a 3x3x3 supercell. Try bigger sizes like 4x, 4x4, or 5x, 5x5 if you can. As you increase the size, check if the imaginary modes go away. If they shrink or disappear, your model is improving. Don't just use the biggest box. Find a balance between accuracy and computer time. Bigger supercells help show if your structure is really stable. This is the first big step to a stable simulation. Now refine your K-point grid for better accuracy. A coarse grid misses details, just like a low-res image. Start with a 4x4x4 grid, then try 6x6x6 or 8x8x8. Check if your total energy and phonon modes change as you increase the grid. When results stop changing, your grid is converged. A converged grid gives accurate forces and stable phonon results. Don't let a poor grid ruin your work. Careful grid refinement ensures reliable phonon calculations. Tip 3. Checking your boundary conditions is absolutely crucial. Periodic boundary conditions let us model infinite crystals. But if your supercell shape doesn't match the material's natural vibrations, you can introduce artificial stress and get misleading results. That's why it's important to relax both the atomic positions and the cell shape, using options like in your simulation software. Sometimes a slightly deformed cell relieves artificial strain and eliminates imaginary modes that aren't really there. Don't just assume cubic is always best. Letting the structure relax to its lowest energy can reveal the true physics. This subtle check can make a huge difference in the accuracy of your results. Always verify if your simulation box is supporting or distorting your model. Getting this right is key to reliable simulations. Let's make pseudopotentials and cutoff energy simple. Pseudopotentials help us model atoms more easily, especially when we have both heavy and light elements. Choose a modern type like PA. If you see problems, try a different one. Slowly raise the cutoff energy until your results stop changing much. If the cutoff is too low, your results might be wrong. Always check both settings carefully before trusting your results. These steps are the basics for any good DFT calculation. Still seeing ghosts? Try using different software like VASP, Quantum Espresso, or a Binet. Use tools like Phonopy for phonon analysis. If the imaginary mode disappears with another software, it's likely a software issue. If it remains, it's probably a real physical effect. Always confirm your results with more than one tool. Tip 6. Always compare your results with experimental data whenever possible. Even if exact data for SrIrH at 100 GPa is scarce, look for similar systems or nearby pressures in the literature. Does your phonon spectrum match key experimental features? This comparison is crucial for validating your simulation. If not, revisit your setup. Ensuring alignment with experimental data is essential. Real-world benchmarks are your ultimate reality check. They help confirm the accuracy of your simulation. Don't trust a simulation that contradicts experiment. Experimental data is the gold standard for validation. Strict convergence testing means carefully checking your simulation settings. Change one setting at a time, like supercell size, K-points, or cutoff energy, and see if your results stay the same. If your results don't change, your setup is stable. It can take time, but it's important for reliable results. Stable results mean your findings are trustworthy. If imaginary modes still appear, it could be a real physical effect. That's how you know your science is solid. There you have it. 7 essential strategies to banish imaginary phonon modes from your simulations. Apply these tips to your own work, whether it's SrIrH₈ or any other material. Share your experiences and tricks in the comments. I'd love to hear your stories. If you found this guide helpful, don't forget to subscribe and turn on notifications so you never miss a new deep dive into computational science. Thanks for watching. Now go build your next stable model and let us know how it goes.